Hey buddy, so thread are important but a confusing concept, right? But we are going to make it very simple today. Okay, so what if I tell you that you are a thread? Yes, you heard it right. You are a thread. Okay, now before I relate you with thread, let's go to the computer world. Okay, in computer world, you are working in for sure one operating system, right? And in every operating system, you do processes, you perform multiple processes. When you open Notepad, that is one process. When you open Visual Studio, that is other process, right? And you do multiple processes. Now, under every process, you perform multiple threads or you perform single thread. For example, in Visual Studio, you go and create one file, interface, class, HTML, XML, any file, right? So that is done by one thread. Now, when you go and update the Nugget package, that is done by other thread. So, and that is why, over internet, if you go and you will see what the definition is, thread is a lightweight process. But what exactly it means? Because thread is something that will perform very small tasks, right? You just go and create one file. That is something called light task. That is why it is called lightweight process, because ultimately it is also a process, right? But what happened in operating system, we have divided process into multiple threads, into single thread. So basically one process is a collection of threads, a task, right? So that is what thread is. Let me repeat again. So thread is very lightweight because we have to perform very light task, very small task, right? And combination of thread become one process, right? And process is what? When you do some operation, when you open a Visual Studio, that is one process. And inside Visual Studio, multiple threads has been performed. Okay, now, why I said that you yourself are thread? Okay, you are working in one organization, right? Every organization have one project. For sure, it won't have one project. It will have multiple projects, right? In every project, multiple people are working on. Not necessarily, sometimes single person is also working. But yes, at the end, people have to work in project to complete that job, to complete that project, right? So the people, those people, whether it's single or multiple, those are working to complete one project. They are actually thread because everyone is writing something, right? Whether they are writing API endpoint, a small task, one person is writing database code, a small task, other is writing UI code, again a small task, right? Those multiple threads to complete one process, right? So now you yourself for sure, working in one project. So you are also a one thread. Now, next time when someone says, hey, what is thread? Think about yourself, right? That you are also a thread. Now in thread, what we are going to do, we are going to talk about single thread, multiple threads. Now, not just these two threads, there are two more subtypes. And those are foreground and background thread. Okay, now, and we are also going to talk about that thread pool, right? Okay, now let's go to the code and let's take a deep look. Okay, so here we are in the Visual Studio and we are going to use this console application, right? Okay, so first of all, let's focus on synchronous programming, and then after that it would be more clear that why we need a thread. Okay, now let's go ahead and create a one method, and I would say this is void method, right? And say this is task one, right? Because in the end we have to perform multiple tasks or single task, right? So let's name it task one, just task one, right? And let's print down something because that is going to help us to understand this concept when we will run this application, right? So I would say that this is what? This is my task one, right? And let's copy this whole method, and over here I would say this is task two, right? And this is task two. Okay, I spelled wrong. Let's say my, and over here as well, my task one, my task two. Okay, now what I'm going to do, let's call it, okay, what I will say, hey, task one and task two, right? So this is task one and task two. Now when I say synchronous programming, that means this code will get executed only when this part is done, right? If this part is not done, we are not going to see the output for this. Now let me show you. Let's execute it. Okay, here you go. You see how it has printed my task 1 and then my task 2, right? So this is how it is working. Now let's do one more thing. Let's add a for loop here. Let's add a for loop. Say for loop where I is equal to 0, right? I is less than 10 and say I plus plus, right? So that will give us more clear picture, and we also need this for loop for a later stage. So let's add that. Here you go. Come on, and let's run this. You will see it will perform task 1 first and task 2, same thing, right? But you see task 1 1 1 1 1, first it completed task 1, all the operations inside task 1. That's why I said for loop, because it will give more clear picture that it is completing all the jobs, all the operation inside task 1 like 10 times, and then after that, once it is done, it has done all the other operations, those 10 operations under task 2. Now this is something called synchronous programming. Okay, you see this code, task 2 has no dependency over task 1. Then why should task 2 wait for task 1 when I don't have any dependencies over task 1? That does not make sense, right? So now here the birth of threadings, right? So what threading means? Threading says, okay, I'm going to solve your problem. Before you were waiting for other people to complete their task, then you are going to do your job. But don't worry, let's go for thread. Okay, so what all you have to do, you have to say thread, and thread comes under a system.threading namespace, right? And over here I already have that namespace. That's why I don't see any issue. Okay, let's create, first you have to create one object for thread, right? So let's name it thread1, right? And what I would say, new, for sure I have to, for creating object, I have to say new and then that class name. This is my thread class, right? See, this thread start crying, right? Because if you go to thread, here I don't see any constructor which don't have anything, right? Every constructor has something, right? Okay, so this says that I need some operations to perform, right? Otherwise I can't work. So what we will do, we will say, okay, you perform task 1. Here you go, right? You see, it is happy now. See, he is that person who don't like to sit idle in the office time, right? He says, keep assigning me work, keep assigning me work, then only I will work. Otherwise, I'm not going to work here. Okay, so you see, now it is happy. Okay, that is good. Now, 2, this is just an assignment of work, that this thread is going to perform this task. But to make this executable, what all we have to do, there is some property called a thread1.start. Here you go, right? The object name, this was my object name, and then you have to say thread1.start, right? That is now good. Okay, let's comment this code. Okay, now what we are doing, this operation is going to perform under one thread, but how this is going to behave over here, we are still not saying that this is going to perform under thread or not. Now let's see how it is going to behave. Let's execute this application and let's focus over the console print. Okay, now I see my task 2 and then task 1. Here you see 2 1 1 2 1 2. That means everything is being performed parallelly. Before, what was happening in synchronous programming, when code was like this only, when there was no thread, let me comment this code. So before, task 1 has to complete and then thread 2 was working. But here you see, sometime it is working task 2, then task 1, task 2, task 1, and so on. That means both the tasks are being performed parallelly, right? So now you will think that this makes totally sense that this was working under thread, but why this? I have not performed any code over task 2, then how it is working, right? That is making me crazy. Okay, so what happened, your application, even don't write any code for threading, this application, right, your application will still work under one thread. Remember, right? Whether you write a thread code or not, your application is still going to work under thread, and that is something called main thread, right? So that is why you see this was one thread that we have created, but the other thread was already working on. So that's why you see now we have implemented multiple thread. Okay, so multiple thread is what? When more than one threads run parallelly. Okay, now let's make this thing more interesting. Let's take a more deep look. Okay, what I will do, I will say task 3 here. Let's make it task 3 and let's print it over 3, right? And let's do something like this just to differentiate between task 1 and 2. And let's say plus plus is task 2 and simple one is task 1. Okay, now if I call task 3 here, then how it will work, right? What do you say? I think as per logic, this will work under one thread, but all the other logic, this logic is going to work under one thread, right? That means, thread 1 will work parallelly with task 2 and task 3. Okay, let's execute this application and run the process. Now you will see here you go. My task 1 and then task 2, that is fine. My task 1 and you see task 3. So that means my task 1 was under one thread, but task 2 and task 3 was under one thread. That is why you see task 3 has waited for task 2 to complete. But task 1 was working parallelly over here with task 2 and task 3 both, right? What if I wanted to run every task under thread? What I will do? I will make threading for every task, right? So what I will do, I will create more tasks here. Let's remove this, and what I will say, this is my thread 2 and let assign thread 2 here, right? Remember, you don't need to make it method over here. If you do that, it will start crying. Here you go, right? You see, cannot convert void to and blah, right? So you don't have to mention the method because it just say assign me the task, don't execute me. And when you specify this function, it's go and start executing, right? So you can't call, you just assign that delegate. Okay, so you have assigned this task 2 to it. Okay, now to call the task 2, to call the thread 2, what you will do? You will say thread 2 dot and start. Here you go, right? Here you go, right? Now similar for task 3. Even if you don't assign task 3 as a thread, still it is going to work under one thread. But let's make it thread as well. Okay, so I'm going to create one more thread for this as well, and I will name it thread 3 and I will assign thread 3 here. Here you go, right? And then I will say, hey, go and start the thread 3. Okay, now all of these 3 are going to work under multiple threads, right? Under their own threads. And then whatever code that you write here, that would be working under a separate thread. Let's call that as a main thread. I would say main thread completed. Here you go. Let's fix this and let's okay, now let's see the magic. Okay, let's see. Enter. Come on, I think I closed it by mistake. Let's run it again. Okay, here you go. You see my task 2 and main thread C completed, right? Because it has nothing to do. It has very small logic which just have to complete, right? So that is why it didn't wait to complete these 3 threads, right? It has very small lightweight process. It has completed very easily. And then you see task 1 is doing, task 3 is doing, and all, right? So 3 different thread, actually 4 thread. These 3 different thread and then one main thread. Okay, now it means we have covered single thread and multiple thread, right? When you don't even write a thread code, that is why itself a single thread. But when you assign a thread, that at that time your application become multiple thread, right? Though you write just one thread, but still your application is going to behave like a multiple threads. Okay, now couple of important thing about thread. So this method, you see task 1, let's focus on task 1. Let's minimize the other code to avoid any confusion, and let's comment these code as well for now, because we have understand the concept of multiple threading. Okay, now let's focus over just threading. Okay, over here this task was without parameter and you see it was happy. What if we assign the parameter? Is it going to happy? Let's see. I'm going to assign one string and let's say this is just test string. Okay, and let's see. Oh, I don't see any error. Really? Now it's good. So thread, it says no, cannot convert from method group to parameterized thread start, right? So that means now what we have to do, right? Go to thread, here you go, right? And it says parameterized thread start. Okay, what is parameterized thread start? If I go over here, you will say it accept object. Now that object, either you assign it or don't assign it, right? If you don't assign it, that means it is happy, right? That was like this our application. When you had no parameter over here, it was happy. Here you go, right? But when you assign any parameter, it start crying. And why? Because it says I can only work with object parameter, right? Nothing else. Okay, let's close this and let's try to make it object now. Okay, what I will do, I will say this is object, right? And let's rename it something better. Let's say obj. Now let's see. Whoo, it is fine, right? So this is good. Okay, now let's put a breakpoint here, right? And let's see how it is going to behave. Okay, so I have executed. Okay, so you see, object is null. For sure it would be null because I have passed the parameter over here. I'm asking for actually a parameter, but I'm not assigning any argument. Now remember, there's a difference between parameter and argument, right? Parameter just a name, and argument the value that we're going to assign. Okay, so where we have to assign the argument, pass the argument, can we assign here? I don't think so, because we just saw that you can't make it a method over here, right? It just need assignment of work. Then where we have to do that? Okay, well, this place over the start, right? This start will accept. You see, start could be without parameter, but start can be with parameter, right? You see, you can pass the object parameter here. Okay, now let's go ahead and assign very simple parameter. I would say just a name. Let's say I passed Praveen as an argument. Okay, now execute it and let's see what happened. Here you go. You see, now I got that, right? Okay, so that is how you can pass the argument. But you know what, that is fine that it was object and it was a very simple string. If I need, I can print out here, right? I can use it. What if it is model? Let's say it is passing one model, or let's say new, and I would say any sort of yeah, I have one DTO. Let's say this DTO it needs, right? Let's say, and come on, let's say equal to, and assign one value to this. Here you go, right? How it will work here, right? Can I say object dot first name? Let's see, object dot, no, it is not coming, right? So how you can do that? You can say, hey, where person and equal to, and for sure you need to mention the DTO that you wanted to convert. This is normal parsing, right? You already know, but still I thought to talk about this because sometimes people make confused and how it is going to behave, right? Now you see it is happy now. Now whatever you need, you can find that person dot first name and last name, right? So this is how it will work, okay, with object. Okay, so this is about parameter, with parameter and without parameter thread. Now there are a couple of more important things about thread other than start, right? There's so many properties, but let's focus on key properties. That is thread dot sleep, the very basic, right? So even if in your code you don't implement thread code, but still to pause your application, to pause your work, you use thread dot sleep. Now you don't now think that if you are not implementing thread code, how thread dot sleep start working? Because by default your application is single threaded application, right? So that is why it works. Okay, now let's use thread dot pause, right? What I will do here, let's say thread dot sleep, actually not pause, thread dot sleep, and I wanted to sleep here, let's say actually 3 seconds, right? And I would say here I'm going to sleep for what? Sleep for 3 millisecond. I believe this is millisecond. Yes, let's increase more, 300 millisecond actually, right? So let's say 300 millisecond. Now let's see, right? So we know this, what it will do, it will pause your application, this process for 300 milliseconds, right? Let's remove this breakpoint now and let's focus over just the console, right? Where is console? Here you go. You see. you see it is taking some time. Every time, you know, when it is performing task, it is sleeping for 300 milliseconds. Now you may think that, you know, it was quite fast. Okay, let's do one thing. Let's, you know, where is that thread dot sleep? Now you may see the difference. Now I'm making it sleep for more millisecond, right? Now let's see the behavior. Okay, here you go. You see my task 1 is done, but still you don't see this code to work because it went to sleep for these many milliseconds, right? So that is what sleep does, right? And I'm damn sure everyone, the people, the programmer, whether he worked over threads or not, he knows that what thread dot sleep is. Okay, now that is one property, right? Let's remove that property here. Now what is other property? Okay, so the other property is, you know, thread dot abort. Okay, now abort is what? Abort means you wanted to just exit from that thread, right? You wanted to cancel the whole thread. Now second thing is thread dot abort. Okay, but you know that thread is not simple, you know, like this. It won't work on normal thread. If you say like thread dot sleep, where is that thread dot abort, you won't see that option, right? Because it needs one thread object, right? So that means it will work over here like this. If I go over here, I say thread 1 dot, here you go, right? Thread dot 1 dot abort. Now where we have to use that, where actually we have to do that, right? So let's, you know, make it a little global over the class level, right? And now an object. Okay, so it's not happy. Oh, okay, I think, you know, because we have to make it static, right? Because we are working on a static class, we have to make it static. Okay, now it is happy, right? So where we have to use that, in what situation? Let's say you are doing some job, right? And in job there is some condition. Let's imagine, you know, let's over here, let's say you check for, you know, if I is equal to 5, right? When you know these many processes done, I wanted to abort that. I don't need that anymore, right? So you can use for those purpose, right? In your application, when there is a requirement that, you know, when these many work is done, when these many data operations are done, just abort that, don't go further, right? That is what our requirement is. Okay, so at that time it will work. What I will say, thread dot abort here, let's say thread dot abort, put a breakpoint here and see. Okay, let's go there. Here you go. Okay, now what will happen? So it is over here, I is equal to 5. When I say thread 1 dot abort, it will completely abort the thread. That means we will face the exception, because if there is no thread, how this application is going to behave, right? So if I say F10, there you go, you see there is some exception, right? Let's close it, but let's look at the over here. You see it didn't complete because it is aborted here, right? So if you want to terminate, and for sure, you know, you can handle that exception through try catch, right? But if in your application there is a requirement of terminating for any thread, you can use that, right? Whether you use it or not, but at least you should be aware of the concept that there is something called thread.abort to completely terminate the thread. Okay, now let's stop it. So this was, you know, thread abort. Okay, let's, you know, remove all this logic and let's say control KD for code formatting. And okay, now coming back to here. Okay, now there is something called thread.join. Okay, what thread.join is, so understand join as a priority. It is like, you know, I have the top priority. So let's uncomment this code and see how it works. So technically, you know, this will complete first and these two things can go parallelly, right? So remove this code from here. Okay, now let's see. Okay, I've executed this application. Here you go. You see my task 1 completed first, and then, you know, these two things done parallelly, right? So that is the beauty of join. Now, you know why they have named it join, why Microsoft has named it join, right? Does it make sense? Why can't they make it, you know, priority? Hey, this is my top priority is equal to 0, top priority 1, and blah and blah. So basically, let's say join is an organizer, host, right? When, you know, you start organizing something, you say, hey, I'm the lead, hey everyone, join me, right? and that means you have to be on the front. Similar concept here. So if you want to remember that concept, you have to understand that thread1 dot join says, hey dude, I'm the leader, come and join me, right? We're going to do the job, we're going to complete the things. Okay, so that is how we can remember the thread1 dot join. Okay, now there are two more things, something called foreground and background thread. Now these two threads also depend on the abort. Okay, when I say abort, that means main thread abort. How main thread completed? When this job is done, because this is the last code, right? Last code of this program class. So that means when this code is done, that means main thread is completed, main thread is aborted, right? So now in the abort there are two types, foreground and background, right? By default everything is foreground. Now foreground says, focus on the name, foreground, for, right? It says whether main job completed, main thread is completed, terminated, right? Whatever it does, don't care, keep moving forward, right? And all those things that we have implemented, those were foreground thread, right? Though it was getting completed, but still it was keep running. And for example, if I can show you the old output, you see main thread was completed here, right? But still the other thread was keep moving forward. They were not caring about the main thread. But in background thread, that was not how it is going to behave. Now let me show you. Let's comment this code, okay? And over here, I don't need join now. What I will say, there is one property, and over here you will say is background equal to true, and that's all. Now you will see it says, task 1 is doing what? Task 1 is saying, I will, run 10 processes, right? Now you will see little different behavior. Let's execute this, and here you go. Come on, let's press enter. Here you go. You know what? Let's do one thing. Over here, let's print something called I, right? And use string interpolation. And now then we will understand this concept. Let's close this. Let's remove the space. Okay, task 1, and say like this. Okay, now you see. Let's execute and let's see what happened now. Okay. Oh, so it has completed everything, right? Thread 0, 1, 2, 3, 4 till 9, and main thread was completed still. Why? I don't know, right? I think I'm wrong, right? I'm stupid, right? Because I said if it is a background thread, then it won't get executed right after this, right? So how we can understand? Maybe the thread job was very small. That is why we don't see the impact. What I will do now, let's make it 10,000, right? Now see if it keeps looping till 10,000 or not, right? This thread. Okay, let's execute. Come on. Hey, come on. Here you go. You see, it didn't, work till 10,000, right? You see, only 30 jobs were completed, and soon this main thread was completed. It just aborted, right? So that means when you say is background, it follows the order of main thread, right? Main thread says to this thread, hey dude, when I am done, you have to complete your job. No matter you have completed your job or not, I don't care. You have to stop right away. You have to move backward, right? And that is what it is, background, right? Background thread. Okay, now to understand this concept more deeply, let's do one thing. What I will do, I will sleep the thread, okay? I will say, hey, before you complete, let's come on thread dot sleep for some time, maybe 1000 millisecond, right? I think it is 10,000. Let's say 1000 milliseconds or 10,000, doesn't matter, right? So now you will see little interesting thing. You see it is keep running, and the reason is why, because we have paused the code here, and that is why, right? So once this will wake up, here you go. You see when you made a pause here, thread dot sleep, it kept running, but when there was no thread, it is not running that that long. Here you go. If I can show you again, you see it was not able to complete the job, right? Okay, so that is background thread. Okay, so this is fine. Now what, let's remove this code. We don't need these codes now. Okay, fine, let's close this. Now there is something called thread pool. But you know what? Why we need a thread pool? Why we need a thread pool, right? What was the need of thread pool? Okay, so this thread is totally used by your operating system. When you say thread, code that we have just written, those codes were handled by your operating system, and for that you have to do a lot of extra effort. You see, you have to create object, right? You have to create object every time. Whenever you need to create object, right? So that means these threads, as a developer, you have to handle yourself object creation, and also if you wanted to clean the memory, you have to do by yourself, right? Now there is something called thread pool. What thread pool says, that Microsoft has introduced something called thread pool. Now thread pool says, as a dev, you don't need to worry about, right? Every object I will take care. This manual thread was little costly. Now why it was costly? Because every time, for every task, you have to create a new thread, right? Now if you have 200 requests, that means 200 new objects, thread objects, right? That means if there are too many requests to your system, right, so that will make your system slow. But in thread pool, it doesn't happen. In thread pool, let's go there. Here you go, right? So where is thread? Here you go. You see, in thread how it works. You start the thread, right? Object is created, memory resource is assigned, and operation is performed, and at the finally garbage collector is performed. Now you know how garbage collector work, right? But in thread pool, what happen when there are multiple requests? It is not directly go and create object. No, that doesn't happen. There is something called pool, right? There is something called pool, and in pool what happen? It take care of starting the object, executing it. When the work is completed, instead of garbage collection, see, it returns to thread pool. Now when that thread is free, other task is assigned to that thread, right? So that is why it is not costly, but thread was costly. Now in real life, you wanted to understand this concept, just think about your organization once again. There is a one project requirement where they need one new member to work. What they will do? In thread case, if they have to go this route, every time they have to hire new person, right? And that is going to cost a lot of to that company. But if they have let's say one Excel sheet where they maintain one pool, where they maintain all the people who are on bench, right? So let's say now there is any new requirement. Let's say there are 3 projects in queue. So when people are working different project, and if they free from that project, what they will do? Instead of hiring a new resource, they can assign the other project to that people, instead of hiring from the market at the higher cost. Because when people switch the company, they ask for higher money, right? Same concept here on the thread pool. Okay, so let's go there. To implement the thread pool, what do we have to do? There is a class called thread pool. Before it was thread, now you have to say thread pool. Let's go here. Let's go here and say, let's remove this code. Okay, so let's remove this code, this as well, and this as well. We don't need it. Okay, let's clean up. Okay, so we have to say thread pool. Here you go, right? And then you have to say this. There are many more property, and there are many ways to implement thread pool, right? But this is one of the way that we need to talk, that we're going to talk. So that is something called queue user work item, right? Queue user work item. Okay, now if you say like method over here, now you see I'm not going to create any object here, right? And what I will do, similar way, I need to perform one task, which is task 1. I will say task 1, right? But it is still, right? So you see task 1, and that's all. My job is done. Now let's say there are 10 requests, 10 different requests, right? Here you go. Let's see, let's print out over here and say this is main thread. This is main thread. I think I messed up something. Let's say this one, and let's I think this is fine. Yes, this is fine, right? So this is main thread, and I'm not going to do anything. Doesn't matter, right? I don't care how many objects I have to create for each work. So let's make it 10 only. Okay, let's not 10 also, let's make it 5, right? There are 5 requests. So now let's see, if I execute it, Now you will see how thread pool works. You see, these were the main thread, right? 0 to 4, that means till 5, less than 5. Okay, now these were the main thread, that is fine. Now here, if you go to task 1, which was assigned to this this thread pool, this was supposed to run till 10,000, but I don't see anywhere it was running till 10,000, right? Every thread for these 5 different threads, it was running like 0010. I don't see why, right? So thread pool is a background thread. We don't have to specify. So thread pool is only used when there is a very short work item we have to perform. If you have to go for long duration task, you have to create manual thread that we have just created before. But if there is something short, you can use at that time thread pool. And remember, thread pool is background thread. So soon this main thread is completed, this also have to stop right away, right? This is very attached to this because thread pool is background thread. Okay, now let me repeat one more time. Single thread, by default your application is single thread. Now when to use thread programming? When you wanted to perform multiple tasks at the same time, and those tasks are not related with each other, so you can speed up your application performance, right? Okay, now there is a concept of foreground thread and background thread, right? So by default all the threads are foreground thread except thread pool, right? So thread pool is background thread. But if you wanted to make something background thread, right, explicitly, then you have to specify dot is background property, right? And then there is something called join. So join always have the highest priority, right? Okay, so that's all for today's video. I will see you in the next video.